Good morning. Today we're doing a review of lines. So we're going to do one problem of each section together, and then you guys are going to try a couple of them on your own. So we're going to start with example number 1. It says write the equation of a line that goes through the points 1, -2 and 4, 4 in slope-intercept form. And we wanted to remind you that slope-intercept form looks like y equals mx plus b. So in order to do slope-intercept form, we need two things. We need to find the slope, and we need to find the y-intercept. So we're going to start by finding the slope first. So on the side of your paper, we are going to write down slope and our slope formula. So our slope formula is that y2 minus y1 over x2 minus x1. So usually what I like to do with these types of problems is I start by just labeling the 2 points that I have. So here's my x1, y1, and my x2, y2. So then I can go ahead and plug those points into my slope formula. So I have y2, which is 4, minus y1, which is a -2. Over x2, which is also 4, minus x1, which is just the number 1. So on top, remember when we have minus a negative, that turns into a plus sign, so that's really just the number 6. And I have 4 minus 1 on the bottom, which gives me 3. So to simplify that, my slope is just the number 2. So that's my first step. I found the slope. Second step, I want to go ahead and find the y-intercept. So I'm going to do this one in a purple color. To find the y-intercept, we're going to go ahead and use that y equals mx plus b equation. So I'm going to write that down here. Now using that equation, we're going to go ahead and plug in all of the information that we already know. We know that we have an x and a y, and that can come from one of our points. So I'm going to go ahead and use this point, the 4, 4. I'm going to use that one because both of my points are positive there. It doesn't matter which point you use in this case, but because these are positive, it might be easier to stick with the positive numbers when plugging it into the equation. So the y value of that point is 4 equals m. Well, we found above that our m is the number for our slope, which we said was the number 2. So I'm going to go ahead and plug that in. Times x. That x comes from that x value in our coordinate, which is also 4. And then plus b. And we do not know what b is, so we're going to leave it as the letter b right now. And we're going to go ahead and solve. So the only math that I see on that right-hand side is 2 times 4, which gives me 8, plus b. And then I want to get the b by itself, so I'm going to go ahead and subtract 8 on both sides of my equation. And that leaves me with -4 equals b. So that is our y-intercept. Now that I have my slope and I have my y-intercept, I can go ahead and put it all together into the equation. So the final equation, putting it all together in slope-intercept form, is y equals mx, which is the 2x, and then plus b. And we said that b is the number -4, so -4. So we're just putting it all together. In your final equation, you should have an x and a y. So make sure that you don't plug in numbers for those. You actually have them as your variables. That is your equation of your line in slope-intercept form. You guys are going to try examples 2 and 3 and 4 on your own with those. Come back to example number 1 if you get stuck, or come to Zoom if you have any questions. And when you're ready, you can continue on the video to example number 5 that we're going to do together. Example number 5 has us writing the equation of a line that goes through the points 4, -2 and -4, -8 in point slope form. And then again, they reminded us of that formula, y minus y1 equals m, x minus x1. Now, I like point slope form better because I think it's actually a little less math that we have to do. So we're going to start by figuring out what two things we need for point-slope form. First, we need a point. We have 2 points already, so we're good there. But the second thing we need is the slope. So just like we did in that first example, we're going to go ahead and find the slope between these 2 points. So let me write down the formula again just so that we remember it. The slope formula is y2 minus y1 over x2 minus x1. And then I like to go ahead and use my points and label them. So x1 and y1 and x2, y2. So now I can go ahead and plug that information into my slope equation. So y2 minus y1 is negative 8 minus a negative 2. And then on the bottom, I have negative 4 minus 4. So on the top of my fraction, again, I like to turn that minus a negative right into a plus sign. Negative 8 plus 2 gives me negative 6 on top. And on bottom, negative 4 minus 4 gives me a negative 8. And then we always want to simplify our fraction if we can. So I can divide the top and the bottom by a negative 2. And when I do that, I get a positive 3 over 4. Right? Because a negative divided by a negative just gives me a positive. So my slope is positive 3/4. Now, we're going to go ahead and write the equation in point-slope form. There are 2 different answers that you can have here. So I'm going to give you both of them just so that you have an idea. So let's start with, and I'm just going to split it in half. Let's do the point 4 comma negative 2 first. So that's this guy. I'll put it over here in the corner. 4 comma negative 2. So if I was using that point as my point for point-slope form, I'm going to go ahead and start by plugging in what I know. So I know that I have y minus y1, which in this case is the number negative 2, equals m, which is my slope, and we said that the slope was 3/4. And then I need those parentheses again, and we're going to have x minus x1, which is the number 4 for this point. And that's it. But the last step we need to do is just clean this up anywhere that we see a minus, a negative. So I'm just going to take this and change it into, instead of y minus negative 2, y plus 2 equals my slope, which we said was 3/4. And then I'm going to leave that other piece as x minus 4. You do not have to do any other work. Do not distribute. Do not change it. This is your answer in point-slope form. Now, that would be your answer if you chose to use the point 4 comma negative 2. If you decided to use the point negative 4 comma negative 8, that's fine as well. It does not matter which point you use, but we're going to go ahead and do that answer also, just so that you can see it both ways. So again, with this one, we have y minus, and the y value is negative 8, equals the slope, same slope that you found above, 3/4. And then you have x minus your x number, which in this case is a negative 4. So here we see a couple minus and negatives, and those you just want to change into plus signs. So it's going to become y plus 8 equals 3/4. And then that's going to turn into x plus 4. And that's the only work that you have to show there in terms of changing that into point-slope form. So you do not have to show both equations for every single problem. We only want to see one equation, but it doesn't matter which point you use. When you're ready, after you complete 6, 7, and 8 on your own, come back to the video and we'll go over example number 9 together. Example number 9 goes over some graphing that we've done this year. So first we want to turn any equation that we want to graph into slope-intercept form before we can go ahead and graph it. So the equation that they gave us is y plus 4 equals negative 1/2 x minus 4. So I'm just going to bring this down over here and rewrite it. We have y plus 4 equals a negative 1/2 x minus 4. So to turn this into y equals mx plus b, which is our slope-intercept form, we want to start by getting the y by itself. We also see that there's that negative 1/2 in front of the fraction, or in front of the parentheses, and that guy you want to distribute before doing anything else. So I'm going to keep what's on the left-hand side, y plus 4, and when I distribute that negative 1/2, it becomes a negative 1/2 x, and negative 1/2 times a negative 4 gives me a positive 2. Now that I have that, I want to get that y by itself on the other end, so I'm going to go ahead and subtract 4 from both sides. And I have now the y by itself equals a negative 1/2 x. Positive 2 minus 4 is just a negative 2. So that right there is my equation that I can go ahead and graph. So just a quick reminder on graphing if you need some help with it. The negative 1/2 up front, that's your slope. And slope tells us how we move on a graph. So we're going to move by going negative 1 and over 2, or down 1 and right 2. The other piece of this equation is that negative 2, and that's where we begin, which is our y-intercept. So we're going to start this equation by graphing the point negative 2, or 0 comma negative 2, which tells me I'm going to start somewhere down here. Now that I have that negative 2, it's going to tell me to go down 1 and over 2. So I'm going to go ahead and plot these next couple of points here. Right, we can also go up 1 and left 2, just to extend our line as long as possible. And then we're going to go ahead and connect it because we have an equation. Make sure you have arrows on the ends of your line, something like that. So make sure for each of these next two examples, 10 and 11, you are turning them into slope-intercept form, and then you are going to graph them. Okay, come back to the video when you're ready for example number 12, and that's the last one that we're going to do together. Example 12 is talking about parallel and perpendicular lines. So there are some things that we have to review when talking about parallel and perpendicular. Parallel lines, these lines always have the same slope. That makes them parallel on a graph because they're just running right next to each other. Perpendicular lines have something called opposite reciprocal slopes. And when we talk about opposite reciprocal, opposite meaning if it's positive, we're going to make it negative. If it's negative, we're going to make it positive. And reciprocal just means that we are going to flip that fraction. So let's take a look at this first one. This equation is already in slope-intercept form. So the number that we're really focused on here is that negative 2 over 3. The plus 4 just tells me that my y-intercept is 4, but the slope is really going to help me with parallel or perpendicular. For a slope of a line parallel to that line, we are going to use the exact same slope. So negative 2 over 3 is the slope of the line. Negative 2 over 3 is going to be the slope of a line parallel to it. Now, to take the perpendicular, remember it needs to be opposite. So opposite of a negative number would make it positive. And the reciprocal of 2 over 3 is just going to be 3 over 2. So that is my perpendicular slope of that line that was given. Now, before I leave you guys, there's one last thing that I wanted to talk about, and it's going to help you with example number 13, and it was hoi vux. So we spoke about this earlier this year. Remember that hoi is talking about a horizontal line. So it's a line that looks like this guy. It has a 0 slope. And it's a y = equation. So the other one was vux. Vux meaning it's a vertical line. This one has a slope that starts with a u. It was called undefined. And this one has an x = equation. So these two lines are actually perpendicular, a horizontal and a vertical line, because they do create that 90-degree angle. So keep that in mind when you're going through number 13. If you have any questions, guys, just stop on to Zoom.